If the proton starts moving through space in relation to the observer, there will be a composition of movements in relation to the observer. The curved point motion that forms the proton, which is the proton's rest mass, and the new motion through space performed by the proton form the mass of the proton in motion relative to the observer. If it were possible to install a clock next to the proton, the observer would measure that time now passes more slowly on the proton's clock in exact proportion to its new movement through space. The faster the proton travels through space in an always exactly proportional way, the slower the time on the proton clock measured by the observer will pass. In a clock that could be placed next to a photon, the time measured by the observer does not pass. As the photon has no rest mass, it never performs a combination or composition of movements in relation to the observers. Every photon is always at the maximum possible physical displacement through space in relation to the observer. The speed of light is the maximum possible through space for an observer, so in an exact proportional way, the time measured next to the photon does not pass to the observer. What is time displacement? It is a comparison between two movements. When I find a proton in the same state of rest, that I measure the time of the proton, that is by looking at the movement of the hands of a clock, I compare the proton to a standard measure of movement that we call time. When the proton travels through space relative to me, the clock that stayed with me measures a greater temporal displacement for me than I measure on the clock that traveled along with the proton, which physically means to me that time is passing slower for the proton than for me. Photons never perform a composition of motions. It is not possible to place photons at rest with an observer because they have no rest mass, as they do not present compositions of motion. By presenting mass when at rest in relation to an observer, a proton can perform many compositions of movements in relation to the observer from the situation of rest to almost the speed of light. For an observer, the relative motion of the proton occurs through space and time in an exactly proportional way. The faster the proton travels through space, the slower it travels through time, so that the sum of the travels through space and time always gives the same result. This proportional shift in displacements through space and time does not happen with photons. Because it is very simple to have no mass when at rest with respect to the observer, and it is never a composition of motion, the photon does not travel through time. Photon time does not pass. Its displacement through space is always as fast as possible in relation to the observer. All motion can always be assumed to be also in a perfect state of rest in relation to empty space. Despite always presenting the same speed to observers for the universe, due to the continuity of empty space that leads to the inexistence in the universe of absolute references for movement, light is always at rest and does not perform any movement. The continuity of empty space, its characteristic of absolute inseparability or unity, leads to the inexistence of absolute references for movement in the universe. Every movement is always also a perfect rest. That means no matter what our speed relative to anything, we are always in perfect repose in relation to space. That is why we can always admit that time passes as quickly as possible in our frame of reference. It's not exactly correct to say that we move at the space. Matter does not move at the space. Matter moves for space just as matter occupies no place at the space, but it takes up place of space. The measurements of space depend on the movements to exist, the movements of measuring them, for the observers, just as matter is also nothing more than a quantity of movement in relation to the observer. Thanks for watching. Subscribe to my channel and give me your like if you enjoy it.